Let's talk about graphing linear and absolute value inequalities. So now instead of graphing at a number line, we're gonna move to the coordinate plane. In order to graph an inequality, you really need to remember how to graph a line, an equation of a line, I should say. So putting something in slope-intercept form is the best move. You always start with your y-intercept. So remember, the y-intercept is the number that's without the x. So for us, this is 0. So I'm gonna place a point at 0 on the y-axis. And then the slope is your rise over run. So that's the number that's with the x. And from the y-intercept, you're gonna go up 3 over 4. So you're really just counting here, and I'm gonna go up 3, 1, 2, 3, over 4 again. And I'm gonna go in the opposite direction as well, because I want my line to completely cover the coordinate plane. Okay, and then we're just going to connect the dots. So that is how you graph a line. So if you look at the example on the right-hand side, notice this is not in slope-intercept form. So I recommend putting it in slope-intercept form first. So I'm gonna move the x to the right side. So if I subtract x from both sides, I get negative x minus 2. Y-intercept is negative 2, so that's right here. And then my slope is a negative 1. So that means I'm going down 1 to the right 1, down 1 to the right 1. If you have a negative slope, your line needs to be going in a negative direction, okay? So if your slope is negative, your line should not be going in an upward direction. That doesn't make sense. So you only go negative one time when you're doing rise over run, okay? So don't go down 1 to the left 1. That doesn't make sense for us, because then your line would be going in a positive direction. All right, so you can pause the video and read through this. With inequalities, you need to shade the region that's represented by your solutions. So we will shade here, and instead of open and closed circles like we do on the number line, now we have dotted versus solid lines. So if you have less than or greater than, that's always a dotted line. If you have less than or equal to or greater than or equal to, that line should be solid. So make sure you understand the difference. Also, here is a list of how to graph a linear inequality. Okay, so just make sure you follow these steps, and we're gonna actually see them in action with our first example. So you always wanna make sure that the y is by itself, so we are alone here. So we're gonna start graphing it just like we would graph a line, or like an equation of a line. So we started our y-intercept. Remember, you always have to put the point on the y-axis. And then our slope is 3 over 1. So I'm gonna go up 3 over 1 from my y-intercept. And it's extra important to cover the whole coordinate plane when you're doing inequalities. Okay, so I placed all my points. Now I'm gonna ask myself, do I need a dotted or a solid line? The sign is greater than, so since there's no or equal to, it's gonna be a dotted line. And then I have to shade. So the way that you shade, or the way that I teach how you shade, is you find the y-intercept, okay, so that's right here. And since we're greater than, we go above the y-intercept. The side with my highlighted arrow, which is kind of hard to see, is the side of the boundary line that you shade, okay? And you shade the whole side of the boundary line, not just above the x-axis. Okay, and then we'll put little arrows on the end of our line. All right, that's how you graph a linear inequality. All right, here's another example. See if you can figure it out. So I'm gonna move the x over. So now I have negative 2y is less than negative x plus 4. Notice I put the x first because slope-intercept form. Now I have to divide by negative 2, and I have to divide everything by negative 2. So that's gonna cancel here. I divided by a negative, so I have to flip the sign. Don't forget that. This has an imaginary 1 in front. So negative 1 divided by negative 2 is a positive 1/2. And then 4 divided by negative 2 is negative 2. All right, now I'm gonna place these points on my graph, start at the y-intercept, and I'm going up 1 over 2, up 1 over 2, and then I'm gonna go down 1 to the left 2. Then I ask myself dotted or solid. This is greater than, so we're just going dotted, not solid. And then I ask myself about shading. Find the y-intercept, it's greater than, so we go up. So I shade this whole side of the boundary line. Practice makes perfect. Let's try again. So I'm gonna move the 4x over. So I have 2y is less than or equal to negative 4x plus 4. Divide everything by 2. I don't have to flip the sign here because I'm not dividing by a negative. And now I'm gonna graph. My y-intercept is 2. My slope is negative 2. So I go down 2 to the right 1, down 2 to the right 1, so on and so forth. And then I ask myself dotted versus solid. This is less than or equal to, so it's solid. And now I shade, so I find my y-intercept. It's less than, so I go down. So this whole side of the line is shaded. All right, so now we have a word problem. A tutoring company advertises that it specializes in helping students who have a combined score on the SAT that is 900 or less. So 900 or less is gonna be less than or equal to 900, okay? Because it could be 900 or anything smaller. Write an inequality to describe the combined scores of students who are prospective tutoring clients. X represents verbal, Y represents math. Okay, so don't overcomplicate this. This is simply X plus Y is less than or equal to 900 because it's a combined score of verbal and math. If you were to graph this, we're only graphing in the first quadrant because you can't have negative verbal and math scores, which is lucky for you. So we're gonna subtract X from both sides. So now I have Y is less than or equal to negative X plus 900. So let's just say we're counting by 100s here. So 0, 100, we'll call this 200, 300, 400, 6, 7, 8, 9, and this will be 1,000. And we're gonna do the same scale on the bottom, counting by 100s. So we have verbal on the bottom, math on the left. We plot our y-intercept, which is right here, and we're just going down 1 over 1, okay? So this is a sketch, as you can see, it's not gonna be perfect. Down 1 over 1. This is gonna be a solid line, so we're gonna connect. And when we shade it, we shade below the y-intercept, so it's all in here. And what happens is you can pick any point in here, and that combination represents the verbal and the math scores. So the point that I just placed looks like I have it at like 200 verbal, 400 math, and that fits the bill for this scenario. All right, now we're gonna talk about graphing absolute value inequalities. The main thing you need to know here is that absolute value graphs are always in the shape of a V, okay? And when we shade, now we're going from the vertex instead of the y-intercept. You need to remember your transformations in order to graph absolute value inequalities. So briefly, if you have y equals the absolute value of x, what happens is if there's a negative in the front, that flips the V upside down. A plus or a minus on the inside moves the graph horizontally, so left or right. And this is where it gets a little tricky. It moves it left if it's plus, it moves it right if it's minus, okay? And then a plus or a minus outside moves it up or down. A plus moves it up, and that actually makes sense. A minus moves it down. So it's opposite for the horizontal shifts. Okay, this is gonna help us place our V on the coordinate plane. Okay, so let's get started. The only thing going on in this absolute value problem is this -2 on the outside. In the last slide, I told you that a plus or a minus on the outside of absolute value moves the graph up or down, okay? A minus moves it down. So if you start at the origin, you're gonna go down 2 units. This is gonna be the vertex of our absolute value, okay? Vertex is the point where the V connects. Then when we create this V, we're gonna go up 1, over 1 in both directions, okay? So now we're just creating a V. Remember, you wanna cover the entire coordinate plane. And then you ask yourself dotted versus solid. Well, this is greater than or equal to, so it's gonna be solid. These are just sketches, it's obviously not perfect. And then when you shade, now you start from the vertex instead of the y-intercept, and it's greater than, so we go up. So the inside of the V is what's shaded. All right, this one's a little trickier. We're gonna start by isolating the y. Oh, I don't want it that way. So we'll do +4 on both sides. Don't add the 4 to this one. Don't add it to the 2. It just goes on the outside, like so. Okay, now we have to figure out how we're actually going to graph this. So the 2 in the front, if there's a number in front of the absolute value, that's like the slope of the V, okay? A plus or minus on the inside, remember that moves it left or right. Minus moves it right. Remember, it's the opposite direction that we would have thought. And then a plus or minus on the end is the up or down. So this is going with the plus sign up 4. So when we create our vertex, or when we plot our vertex, we need to worry about the shifts left and right and up and down. So if you start at the origin, we need to go right 1 and up 4. So we land right here. Okay, up 4, right 1. And then we have a slope of 2. So from your vertex, you're going up 2 over 1, up 2 to the left 1, up 2 to the right 1, up 2 to the left 1. And then you ask yourself dotted versus solid. We're solid. And now we highlight, or shade, I should say, and we're greater than, so we go up, so the whole inside of the V again. So if you went down, you would shade the whole outside of the V. All right, one last example. Go ahead and see if you can figure it out. We are going to isolate the y. So now we have negative y is less than the absolute value of x plus 2 minus 1. Divide everything by -1. So this is what happens. The negative in front of the y cancels. You put a negative in front of the absolute value. Notice nothing inside the absolute value gets a negative. Okay, so nothing inside gets this -1. But this, you have to divide that as well, so that's gonna change. So the negative goes in front of the absolute value, and then anything on the outside is affected. So this is what we're graphing. Okay, so now the negative in the front, remember, flips the V upside down. A +2 is gonna move it left 2, and a +1 is gonna move it up 1. So if you start at the origin, we need to go left 2, up 1. And remember, since our V is flipped, now we're going in a downward direction. So I'm gonna go left 1, right 1. And I'm just gonna fill this whole thing in on both sides. And when you're done filling it in, you ask yourself dotted or solid. This one is gonna be dotted. You guys, I made a mistake. Did you catch it? The mistake is I divided by a negative, so I needed to flip the sign. Hello. Don't be that guy. I was just that guy. So this should be y is greater than this whole thing. Hopefully you caught that. Don't be that guy. Okay, when you shade, we go up. So we shade the whole outside of the V. Okay, when you're doing this, don't make the same mistakes that I just did. Remember, if you multiply or divide by a negative, you have to flip the sign. That's a wrap on absolute value and linear inequality graphing.